Hello everyone, so today we're going to be doing the washer method for applications of integrals for Calculus 2. Alright, so this problem we have here, we have x equals y squared and x equals 1 minus y squared. And we're rotating about x equals 3 right here. Alright, we're rotating around x equals 3. Okay, so when we have this is, I already drew out the functions and everything. So we have this is our shaded region, okay? We're going to be rotating this about x equals 3. All right, so we're going to draw another one of these right here. It's a bit of a bad drawing, but right here, okay? And that's going to be rotated around x equals 3. And now we're going to be using the washer method. So the washer method is basically this, all right? We are drawing a washer just like that. All right, it's basically, if you can barely see that, but it's basically this, right? A washer. It's like what you'd use with like machinery and stuff. Okay, so this is our washer here, okay? And this is what our basic washer method equation would be. Okay, so this is what our washer method equation would be. It would be the integral from a to b, whichever bounds, pi times the outer radius squared minus the inner radius squared. So this is our washer method equation. All right, so now let's get to solving right here. So let's evaluate this function right here, this drawing, all right? So the outer radius, okay? Here, let me draw this in better, all right? Okay, so look here. Our outer radius is this right here, okay? That's the outer part of our function. The inner radius would be here, all right? So this is the outer radius here, and that corresponds to this, all right? The inner radius is this, and it corresponds to this, all right? So now, from our original drawing here, the outer radius, all right, the outer radius here, since it's flipped, all right, this is still the outer radius. So the outer radius here is x equals y squared, all right? And then our inner radius would be here, all right? And that corresponds to this here, the inner part. And that would be x equals 1 minus y squared, okay? But here's the thing, this is a more complex washer method problem because we're rotating not about the y or x-axis, but we're rotating about a vertical line, right? X equals 3, okay? And then since we have a vertical line we're rotating about, our radius is going to differ, okay? So our radius, all right, let's label this our outer radius, okay? Whenever you're dealing with these radii here, you always want to do right minus left, all right? For vertical line, when you're rotating about a vertical line, like x equals 3, and the function lies to the left, it's always going to be right minus left. So our outer radius here would be this guy right here. So it would be x equals y squared. But we got to take into account the right minus the left, all right? So it's going to be 3 minus y squared. That's our outer radius. Now our inner radius would be this right here, all right? The inner radius, which would correspond to x equals 1 minus y squared. But account for the right minus left. So these are our inner and outer radii. But let's say our function was here, all right? Our original function was here, and then we were rotating it, okay? So our original function was here. Our radius would then be this minus this, the right minus the left, okay? But now in this case right here, our case, it's going to be right, which is 3, minus the left, okay? So these are our radii. And now we got to find, and we are integrating with respect to y, because look at this. This washer would be represented as dy, all right? Because we're basically like rotating this and filling it up, okay? Like, look, if we do a bunch of mini washers, okay? A bunch of mini washers, they would all just stack on top of each other in the vertical direction, corresponding with dy. However, if the washers were going, say, horizontally, like that, like going across like that, it would be going in the horizontal direction corresponding with dx, okay? Okay. And now to find our bounds of integration, we set y squared and 1 minus y squared equal to each other. We would do y squared equals 1 minus y squared, okay? So this would be our bounds of integration from negative root half to positive root half, all right? So we're going to set up our integral. It will be from negative root half to positive root half, okay? And now we have pi times our outer radius 3 minus y squared minus our inner radius 3 minus 1 plus y squared. I just simplified a little bit, minus 1 plus y squared. We can also simplify this a little bit more. There we go, 2 plus y squared. All right, and then dy at the end. All right, and now the hard part is over. This is the hard part here. These questions will get you when drawing it out and setting up the equation. But now we're on to the easy part. So now what we want to do is, let's simplify this integral just a little bit. Let's pull the pi to the outside. And then I'll simplify all this up. I'll FOIL this and FOIL that. Okay, so I simplified this, I FOILed it out, and then I distributed the negatives. And now, actually, this can actually be simplified even more. So this right here is our final integral, and now we're going to integrate. Okay, so now when we integrate this, it's going to be, so the antiderivative of 5 would be 5y minus 10y to the third over 3 from negative root half to positive root half, just like that. Okay, and now plug it in. So 5 times root half minus 10 times root half to the third all over 3 minus pi times okay. So now this is a bit ugly to simplify, so I will simplify this and I will be right back. So I simplified it out a little bit. This integral is a bit complicated, but the main part of the video was just the setting up part. but we'll finish this problem up. So we got 5 pi plus 5 pi, which is 10 pi root half. Yep, minus 5, which is minus 10 pi root half all over 3. And now we can common denominator this. And that's our answer right there. All right, thanks for watching.